All right. What I want to do now is give you a couple of examples, kind of like I did the last time. I'm going to move this up a little. I don't know if my video is recording enough of this or not, but let's see. So, this example, how many molecules are in 2.12 moles of propane? So we are going to start with 2.12 moles because we always start with what's in our problem. For no apparent reason, the abbreviation for mole is MOL. I'm not really clear why we need an abbreviation for mole, especially because this would be a great abbreviation for the longer word molecules, but alas, I don't get to choose. So 2.12 moles, and we're going to set up our dimensional analysis. Now we need a conversion factor. Our conversion factor is that 1 mole equals 6.022 times 10 to the 23 anythings, right? In this case, it's asking us for molecules, so it's equal to that many molecules. All right, so we have moles up here. What unit's going to go on the bottom? Moles. And according to our conversion factor, it's always 1 with the moles. So 1 mole, 6.022 times 10 to the 23 molecules. All right, we're going to multiply across the top, and we're going to divide by what's on the bottom. It's going to be very important that you type this number in correctly in your calculator, especially if we are dividing by scientific notation. So the best way to type this in so that you don't have to worry about whether or not you put parentheses or anything like that is in your calculator, type 6.022. And then you have an EE button. So I think it's above your comma if you have a TI-84, but you're looking for 2 capital E's. A lowercase e is completely different, right? And this here takes the place, make sure you're doing second, what you need is this EE. So this here takes the place of times 10 to the. So you type 6.022 and then shift to get this EE. And then all you have to do now is type in the 23. All right, so don't put the times, don't put the 10, don't put the exponent sign, just 6.022 EE 23. And now it treats this whole thing as a single number like this, right? We're going to multiply across the top, divide by what's on the bottom. Of course, I didn't do this beforehand. That would have been helpful. If you are using your phone, though I would prefer that you not, you still, if you turn it sideways, still have that EE button. So I'm going to do 2.12 times 6.022 EE 23. And what my calculator spits out looks like this, 1.2766. I'm just going to round it to 1.27. Or I guess 1.28 would be better rounding. So 1.28 E24, or yours might have a capital E24. This is not a number. This is a calculator notation. Your answer is 1.28 times 10 to the 24 molecules. All right, so you need to write it out as a number. I'm not okay with reading calculator notation. I need to know that you know what this means, right? All right, question 2. Let's try one more. So again, we're going to do dimensional analysis just like we did the other day. We are converting, this time, atoms to moles. So we know 1 mole is equal to 6.022 times 10 to the 23. In this case, we're talking atoms, but this could literally be anything. It could be donuts. It could be the animal moles. I highly recommend that you watch the video, the next video. It's about 6 minutes long. It's from a book called What If? And the question is, what if you had a mole of actual moles? It's hilarious, but also pretty gruesome. They can't even put them on Earth. You have to actually make a whole new mole planet, but it'll give you an idea of the sheer scope of this. But also that you can have a mole of literally anything. But anything other than atoms would be a bit unwieldy for Earth. So we're going to start with the number in the question, which is 1.25 times 10 to the 23 atoms. We have atoms here. So what unit are we going to put down here? Has to be atoms. Our units have to match diagonally. That's how dimensional analysis works. The whole idea is we cancel out units until we're left with the thing that we want. So we're going to put times 10 to the 23 on the bottom and 1 mole on top. If we cancel out these atoms, we're left with the mole, and that's exactly what we want. So now we're going to multiply the things on the top, divide by the thing on the bottom. This is where it's going to be extremely important that you're using that EE button when you're dividing especially. Because if you, that was convenient, if you don't use parentheses, it will do your order of operations not the way you want. So parentheses or the EE button. I think probably the EE button is your best bet. So let me type this in. Divided by 6.022 to 23. And what I get is 0.21 moles. All right, if you find yourself getting times 10 to the 46, it means that you didn't use the EE button or put this in parentheses. If you see times 10 to the 46, that should be an immediate red flag that you definitely did something wrong. All right. I hope this helps you with solving these. Monday's assignment will be a practice worksheet converting moles and molecules and atoms.